All right, let's take a look at the asset allocation with two risky assets. All right, so when we look at their returns, there are several cases that you can sort of look at. For instance, in case A, we have two sine waves that seem to be somewhat in sync with each other, and they are positively correlated. You see 0.7 correlation coefficient. They're not the same, but it seems like they go up and down, up and down at the same time. So that's that would be an indication of relatively high correlation. On the other hand, in the case of B, we have negatively correlated assets. It seems to me that they one is going up and the other one is going down at the same time. So they are perfect mirror images of each other. And of course, the correlation is -1 because it seems like whenever the first one goes up, the other one goes down at the same time. Then we have the case of C. Sometimes one of the assets goes up, and the other one goes down, right? And sometimes they go up, sort of at the same time. But then, if you look at the average behavior, you realize that the pretty much half the time they go in sync with each other, and half the time they go in the opposite directions. So on the average, the correlation is 0. Basically, you cannot say if you know one asset, you cannot tell much about the other because the correlation is 0. They're unrelated. They're independent from each other in a way. Okay. So if you look at this slide, this actually probably dispels one of your questions. Look, in the previous slide, you tell me, okay, that's reasonable, but how are we going to make money if the two assets are negatively correlated, right? When one goes up, the other one goes down. So we're not going to make any money because all our profit and losses are just going to cancel. Well, yes and no. In this case, we have an example of two funds, and they are negatively correlated in terms of value. So we have y-axis is the value, and we have time. So the passage of time in this direction, you see that the fund A and fund Z, right? When one goes down, the other one goes up. So they are perfectly negatively correlated. And if you look at the so I have a vertical line here, you see that these distances are pretty much the same. So they are negatively correlated over time, but they both have a long-term trend, and the trend is positive. So in the short-term fluctuations, over this period, over this period, over this period, they are negatively correlated, but over a longer term, they both exhibit a positive trend. So if you mix them together, you cancel their fluctuations over the short term, and you capture their long-term trend over the long term. So that's why you can create this portfolio that has pretty much 0 volatility over a short period of time, but nonetheless goes up in value constantly, predictably. Okay. So covariance and correlation. What we look at right now is, well, how are we going to quantify this relationship of two assets one with each other? And I mentioned the word correlation because we actually looked at that in FIN340, so you are somewhat familiar, but nonetheless, it would be important to review those concepts once again. So what are the measures of interaction between two assets, how they are related to each other? The two measures they have seen in FIN340, and I'm showing in the slide here, are covariance and correlation. So covariance is well, sort of that we probably going to calculate first, and then with covariance we'll calculate the correlation. So covariance is still, we could view that as a more basic measure, but it's also much harder to interpret. It's an input in many formulas, and it's sort of a basic component in many formulas, but interpretation of covariance by itself, it's somewhat hard. Correlation, on the other hand, it's much easier to interpret. It varies from -1 to +1, but it's, to calculate that, probably it's going to be, you're going to need slightly more, you're going to have to make slightly, several steps. So let's look at the example. How are we going to calculate covariance for the situation? So what do we have? We have two funds. We have stock fund and we have a bond fund. All right. So basically we have two assets, and we have several scenarios. We have severe recession, and we have this probabilities, and this rates of return. So for every scenario, say recession, mild recession, normal growth, boom, what we have here is, well, let's calculate the expected mean return that you have in chapter 5. We did in chapter 5. We are multiplying probability basically by this multiplication sign by the rate of return. And, well, 0.05 multiplied by -37 is -1.9. Probably skipping some decimals there, but that's fine. That will be the product multiplication of comps B and C, and the next row in here would be accordingly product multiplications of the comps of probability and the rate of return. And then we sum this. And that's going to be the number 11. Okay. We do the same thing for the bond fund. We sum those numbers, and the sum of those numbers will be 5. And again, what are those numbers? Well, probability multiplied by the rate of return gives us -0.05. Well, we'll round it up. And so on. Well, if in doubt, well, what you can do is, again, as I mentioned in chapter 5, what we'll do is, well, what we're going to do is try to open. Let's just skip out my annotations. I'm going to try to open that particular Excel sheet because the Excel sheet is embedded in this in the PowerPoint. So if you look at the formula right here, you see that this actually is the sum of the -1.9, -2.8, 6.6, 9.0, and so on. And accordingly, this sum is just the sum of the numbers above, and so on. You can actually check that the formulas are correct, rate of return are given, but the product is calculated by the probability by the rate of return. Again, the formula for the mean, we saw that in chapter 5, so you should be aware that it's how things are done. Sorry. Just going to have to go back to our original slide. Unfortunately, if you want to use Excel and to want to use all of this stuff, I have to go between PowerPoint and the other applications. Right. So let's see. Then we have how do we calculate the covariance? Well, for the covariance, we're going to multiply. Here's the formula: probability by the return minus the mean return minus the average return or expected return in one scenario, and then multiplied by the return of the other fund or the other asset minus its own expected return. So basically have this X for the product. So for every scenario, we're going to multiply the probability. The probabilities are, again, here, multiplied by the returns here, minus the standard deviation here. So for every scenario, we're going to do this product of probability multiplied by the deviation of one return versus its mean multiplied by the deviation of the other asset's return minus its mean for every scenario. And then what we're going to do is we're going to sum them. So what you see here in the covariance formula, well, this is the probability, this is the deviation for one, this is a stock fund, then deviation for the bond fund, and then plus 0.25, and 0.25 is already the mild recession probability. And then you have the deviation of minus 11, which is right here. That's just squiggling. Multiplied by the deviation of return for the bond fund, 15 minus 0.5. Not minus 5, minus the mean right here. So the 15 minus 5. And then we do the same thing. We go just down scenarios. So we're going to have 4 terms in our summation. And then we sum them up and we have this result. So minus 71.8. How do we interpret this? Very, well, the magnitude doesn't tell us much. We can compare it with the covariance between other pairs of assets, and then we can just, well, say, compare the magnitudes, but it doesn't tell us much in the sense, well, is it a lot, is it little? Because covariance can be any negative number, 0, or any positive number. So there's no scale, basically. But what we do know is that negative covariance indicates that the two assets move sort of in inverse directions to a degree. Not always, but some of the time, so to speak. We don't know if it's always, most of the time, or maybe 10% of the time. It's really hard to say because, again, we don't really know if minus 71.8 is a lot or not. But we do have some indication of negative relationship between those two assets. All right. So again, if you really want to go into Excel, you just click on Escape and double click on the Excel sheet right here, and then you can see the actual formulas to calculate the covariance. Okay. All right. So, okay. So how do we calculate the correlation? This first spreadsheet that you see, this spreadsheet is called 6.1. Okay. Pretty much the spreadsheet from the previous slide. So in order to calculate the covariance, we're going to use this formula: covariance divided by the standard product of standard deviations. So standard deviation of the first guy, standard deviation of the second guy. And standard deviation is something that we saw in chapter 5, and you also saw in your 320 class. So covariance, well, in order to calculate the correlation coefficient, that's what we're trying to do here, we would need the covariance and standard deviations. What do we have the covariance? If you go back up one slide, you realize that we just calculated minus 71.8, but we do need standard deviations. How can we do those? Well, we have the scenarios, we have rates of returns, so we're going to do the same thing we did in chapter 5 and calculate the standard deviations. Again, we're going to have the deviations of a stock fund's return from its mean, deviation of the bond fund's return from its mean. That's to get our covariance. We just repeat our calculations from the previous slide. It's right here, and 71.8. But we also we get the probability and multiply it by this. So multiply the probability by the square of the deviation, and this is this number. And accordingly, probability by the square deviation of the bond fund. I put the little 2's here, little 2 here, which mean squares. Multiplied by probability will give us 9.8. So we are doing the same thing we did in chapter 5. We're just calculating the deviations, squaring them up, and multiplying by the probability. And again, to get the standard deviation of the stock fund and the bond fund in those scenarios. Then we take the square root. Remember, this is the variance that we're getting. It's the sum of probabilities multiplied by the square deviation. So that's variance. And the square root of 356.6 will give us 18.88. And accordingly for the bond fund. If you want, you can just double click on that particular Excel sheet. If you first press escape, of course. And then you can see the calculations in the Excel sheet. Well, the correlation is right here. It's the same calculation we repeat here. And how do we get that? Well, take the covariance. Again, this number. Then get the standard deviations. That's this number. And then get the standard deviation for the bond fund. This number. So basically, just plugging in numbers from this Excel sheet. And as you can see, standard deviations are, of course, obviously always 0 or positive. So they cannot be negative. So if the covariance is negative, then, of course, the correlation will also be negative. So when we do the multiplication, we can see that the correlation is equal to minus 0.46. It's not a percentage term, it's just a number. So it's unitless, minus 0.46.